Okay, hi everyone. I've had a couple of requests to go through the proof questions from this week's work, so I'm just going to do those on this video here. Okay, so to start off with, it's got number 4 on it. It says prove that n take away 3 is even if and only if n is odd. So if we want to prove this, what we need to do is test both cases when it's odd and also when it's even to show that it only works when n is odd. So if n is odd, let n equal 2k add 1. Therefore, n take away 3 would become 2k add 1 take away 3, which is 2k take away 2. And I can take out a factor of 2 there, so therefore it's even. Now, we need to also check though what happens when n is even. So let's write down if n is even, let n equal 2k. Therefore, n take away 3 would be 2k take away 3. And then this would be odd because there is no factor of 2 that we can take out here. Odd. So we can say n minus 3 is even if and only if n is odd. Okay, so then the next one, which is number 1, the green questions. Prove that n is odd. If n is odd, then n squared is also odd. So if n is odd, we let n equal 2k add 1. Therefore, n squared would become 2k add 1 squared. If we expand that out, we would get 4k squared add 4k add 1. And then you could write this as 2k squared add 2k add 1, because that then shows that it's odd because it's 2 multiplied by a value, this value in here, and then you add 1 to it. Therefore, it's odd. Number 2, prove that the sum of an even number and an odd number is odd. Well, we let even number equal to n and odd number equal to n add 1, their sum would be 2n add 2n add 1, which is 4n add 1. And then this must be odd because we can write it in that form, 2 times a value add 1. So 2 times something add 1. So it is odd. Again, it's quite important with these ones to try and get it in the right expression. So if it is odd, having it as 2 times something add 1, you could let k equal to n, therefore it would be 2k add 1, which is an odd expression. Same with this one up there, we could have let this bracket be something like m or n or something to get it in that form. So if I write that there, just choose m, and this would become 2m add 1. So that is an odd expression. Okay, number 3. Prove that the sum of any 3 consecutive integers is always a multiple of 3. So there's a few different ways you can do this, but I'm going to think of it as if my first number is n, the consecutive numbers would be n add 1 and then n add 2. So their sum would be if I added them all together, which gives me 3n add 3, and you can take out a factor of 3. Therefore, if it's 3 times something, this value in the bracket, it's always going to be in the 3 times table. So therefore, multiple of 3. And again, what you could do here is like let n plus 1 equal k equal 3k. So you can see it's 3 times something. Okay, and then the last one has 2 parts. So for part A, the sum of 2 consecutive multiples of 5 is always odd, is what we want to prove here. So multiples of 5, well, that would be 5n. And then if I wanted the next one in the times table, I would have to add on 5. So the next consecutive one would be 5n, that's 5. And after that would be 5n, add 10, etc. So we want to see if the sum of 2 of them is always odd, so I'm just going to add the first 2 together. Which gives me 10n add 5, and I can take out a factor of 5 there, so it must be a multiple of 5. Let 2n add 1 equal k, it's 5k. So it is a multiple of 5. And then part B, for this one we've got a product of 2 consecutive multiples of 5 is always even. So this one, you could think about it as then timesing something like 5n by 5n add 5, because those would be 2 consecutive ones. But what I get there is 25n squared plus 25n. And it's quite hard in a way there to show that it's always even, because we've got this kind of factor of 25. So what I would instead be thinking about for this one is start thinking about the numbers in the 5 times table. And you can notice that they go odd, even, odd, even, odd, even, odd, even. And it just continues like that. So no matter what we do, if we times 2 consecutive ones, we're always going to times an odd by an even. So that would be the same as doing 2k add 1 times 2k, which gives us 4k squared add 2k. And that definitely has a factor of 2 that will come out of there. So if I let, m equal 2k squared plus k, this equals 2m, therefore always even. So I think looking at the actual numbers on that one is a little bit more straightforward. Okay, I hope that helped with those proof questions. Remember, there is a Teams lesson tomorrow, Thursday at 11 o'clock if you want to come along for any help on any of the other questions.